Hi, this is Tony and Ian from Tektronix.
Hi.
We're here in beautiful, scenic Conference Room 3 to talk about digital multimeters, DMMs.
With the beautiful wood tables.
So what's the plan for today?
Like our last video, we kept it simple. We're just going to talk about the main features, and we're going to give you some examples of how you would use a DMM.
Okay, well let's jump right into it.
Okay.
At its heart, a digital multimeter is a device for measuring voltage, current, and resistance of electronic components. They do a lot more than that, but that's really where it starts.
What you see here is an illustration that mimics what we have actually on the breadboard.
Right, we've got a battery and two identical resistors. We'd like to measure the voltage drop across those resistors, so we're going to put our DMM into voltage mode. We're going to attach some probes to it, and we're going to measure the voltage across both of those. Let's do that now. 0.809 volts and 0.808 volts. So the voltage drop is pretty close.
Yeah, it is pretty similar, but it's a little bit off, and it's so nice to be able to see it here with the digital.
Because back in the old days,
Right.
so this
In
is my
the old days, right?
Yeah, this is my first multimeter, an analog multimeter, and my grandfather gave it to me about 25 years ago by my nearest calculation.
And would this be your grandfather?
That would be my grandfather, yeah.
We'll leave it on here while we talk about it.
All right, so you watch the needle. Do you want to set that down on the table here?
Oh, okay, sure.
And you watch the needle while I attach the probes, and this is 15 volts here. Each tiny tick is 1 volt, so we want it to move about 3/4 of one of those small ticks. That's what we expect.
Okay.
Does it look like it moves about
Yes.
3/4 of a tick?
They look like they move the same.
Right, and they are pretty close, but
Yes.
I certainly couldn't tell the difference between 0.808 and 0.809 volts on
No.
this.
Useful, but
But technology has moved on. Yeah.
Good point. Thanks, Rabba.
So we found the resistances were different by measuring the voltage, but we could actually just measure the resistance directly.
Oh,
So-
and that would require unplugging
Right.
the source,
I'm going
right?
to pull the battery out of the equation, and I'm going to put the DMM into resistance mode. And so we get about 2.166 kilo ohms and 2.163 kilo ohms.
Well, this screen is so convenient. I mean, it's so easy to read.
And so these were supposed to be 2.2 kilo ohm resistors, and got pretty close, certainly
Yeah.
within the 5% of the specification.
Let's talk about some of its main features. You want to go
Right.
through those?
This is the numeric readout. That's what you'll be watching the whole time as an
I
electrical
really like how
engineer.
bright this one is here.
And we've got the main measurement modes, where you can choose voltage, current, resistance, and so on. We've got the place where you attach the probes, and we've got the ability to range and zero, which we'll talk about in a moment.
Okay, we're going to start with the measurements then.
Mhm.
That's a good place to start. So those are down here on the bottom, and there's 5, right?
Yes, there are 3 main measurements, but when you add together the AC and the DC flavors, it really comes out to 5, because you've got AC
Oh,
and
true.
DC voltage, you've got DC and AC current, and you've got resistance. This meter can also measure capacitance. It can measure power and frequency and lots of other things. These are just the bread and butter types.
The ones to get started with.
Exactly, the ones to get started with.
So now we're getting to the hard stuff,
Yeah.
right?
Yeah, there's a lot going on in this industrial design, isn't there?
Yes. I know it's all important, right? For
Right.
safety reasons.
It is, and whenever I'm confronted with a new DMM, I just sort of look for volts and ohms. That's sort of my home base. So I would find this and say, these are the 2 inputs I'm going to be using most often, ground and the input for the voltage probe.
Okay.
And if I'm measuring current, then I will still use this for the ground, but now I will hook my red probe up to either the 400 milliamps or the 10 amps. And this little caution sign and the fused indicates that if we overload these inputs, we can damage our equipment.
So it's important to really realize what you're doing and what you're hooking up to.
Yes. And then these last 2 inputs are for something called 4-wire resistance, which is a more accurate resistance measurement. Topic for a future video, maybe.
Yeah, great idea, and that's a good point. If you guys have comments or ideas of different videos and what you'd like to see, let us know. So now we're moving into ranges.
Right. So as we said, this thing can measure, if it's in voltage mode, it can measure up to 1,000 volts. Though you're usually measuring different kinds of things. If you're at 1,000 volts, you might be measuring some batteries in an electric car all chained together. If you're at the 1 volt level, you might be measuring something really small like a solar cell. When you're measuring a really large voltage, you probably don't care about accuracy down to the microvolt. But when you're measuring something that's a few tenths of a volt on a circuit board, you probably do.
Like things like we just did here.
Exactly.
Right.
And so you want the multimeter to be in the right range for what you're measuring, basically the right ballpark.
And for all you people that like visuals, I've actually included this here so we can actually visualize this.
Excellent. So let's look at the next slide to show how to do that. If you're in a certain mode, like 10 volts, and you need to measure something larger than 10 volts, then you would hit the up arrow, and that would take you to the 100 volt range, and now you can measure something that was dozens of volts. And the other button here, if you hit the range button and put it into auto mode, then the DMM will do that for you. And the disadvantage is it takes slightly longer to do that because it's got to look at what you're measuring first before you get to see it. But the advantage is you don't have to mess around with manually choosing a range.
Okay, so depending on what you're doing, you can decide between the two.
Exactly. And
it is more efficient, is it not?
Right, it's faster to use manual because you're not waiting for the auto range to make up its mind.
Right. Okay. And now I know this is another important feature. All the instruments have them, is zeroing out. What is that exactly?
The DMM is full of electronic components, and all electronic components, their performance changes over time. And so if we were to put this in volts mode and apply a voltage of 0 volts, and again, making sure that we're not in current mode and that we are not connected to the current inputs before I do this, but I'm going to touch the two inputs together and apply a voltage of 0 volts. Now before we set this up, do you remember what it showed on the screen when I did this?
Yeah, it was like 0.03 or something. It actually showed something in there.
Some signal that wasn't exactly 0. And so we touched the two probes together. You can also use a shorting plug for this. And then we press the 0 button, basically telling the DMM, no, that's 0 volts. And so now it's 0 all the way across the board.
I know we've been talking through this the whole time. You've mentioned the safety and making sure you're plugged into the correct place and what you're probing. You want to talk a little more about kind of other safety issues?
I think that'd be good, just to get one final mention in. And it's important to use the right connectors for the signal you're measuring, especially between current and voltage, but also at the right level of current. If you pipe a 10 amp current through the connector that's marked maximum 400 milliamps, you're probably going to blow a fuse. You could damage your equipment. But the other thing to remember is that if you're dealing with something that's up to 1,000 volts, or if you're dealing with something that's up to 10 amps, you've got to worry about yourself too.
Yeah, the whole environment around you.
Exactly. Right? And so be aware of your environment, be aware of your surroundings, be safe with the signals and the equipment that you're working with, and make sure you give whatever model DMM you're using, give its safety section a quick read or a thorough read. Ours is at this address here.
Right. Tektronix.com/learning digital multimeter tutorial.
So that'll get you the manuals, that'll get you information on other types of measurements to do with the DMM, and safety information. All right, well, I think that's a good place for us to sign off. So bye for now.
Yeah, and don't forget to write any comments if you have any.